Hello everyone, my name is Ian Robinson, and this is my project on when to optimize. So what is optimization? Optimization is the process of making something as fully perfect, functional, or effective as possible. This can be applied to any number of things in our world, from code to workflows to even your day-to-day experiences. Now, let's move on to the main focus of this presentation today, why optimization is so important, and what does it mean to find balance. Now, today we will explore both the drawbacks and the benefits of optimization with some real-world examples and personal insights from me and members of this class. Now, let us begin with the perils of over-optimization and why they can make operations fragile. Tight processes like just-in-time systems can't easily adapt to changes in demand or errors without collapsing. Like we've discussed previously in class, operations can become disrupted from things like natural disasters cutting off supply lines and destroying key pieces to an operation. There could also be sudden increases from tariffs, like what Ralph explained in his presentation. There could be an increased demand for a critical resource because of low supply caused by any number of reasons. Take the global market. It's a rapidly developing and has random changes. You have no control over it and how it could affect your operation if you're not prepared. Collapse can even occur from within your own operation if there isn't enough lead time for a process. Small delays accruing over a period of time could end up bottlenecking your entire operation, which leads to our next peril of over-optimization. Complexity. As a process is improved over time and more layers are added to an operation, it inevitably becomes more complex. And with complexity comes an increased risk of errors. As a process becomes more intricate, there are more steps, more dependencies, more specialized components that must work in harmony with each other. And if there's a single point of failure and no redundancies in place, it could cascade into bringing down entire systems. And that speaks nothing to the hidden costs improvements might have. Complex systems are harder to understand, to monitor, and repair, leading to increased costs for the additional documentation, training, and specialized knowledge that come with growth. As a result, it will take longer to onboard employees and more resources are needed to maintain current systems and performance. As an example, in manufacturing, over-engineered machinery often requires a technician with rare expertise to perform basic maintenance. For each improvement you make, layers of complexity will be added, which might not even pay off in the long run. And this leads us to our final peril of over-optimization, diminishing returns. So, what are diminishing returns? Let's say as your optimization efforts continue, your gains get smaller while the complexity and costs keep growing. As a result, your system becomes inefficient again, but not from the lack of optimization, but from too much. So as an example, you're spending hours tinkering in a warehouse storage for a 0.5% increase in capacity, but it didn't offset the labor costs involved. But now let's focus on some more real-world examples of failures from over-optimization. Boeing. Boeing is responsible for some of the most famous, or rather infamous, cases of failure in the public eye. But for now, let's just focus on one of Boeing's many failures that deal with over-optimization and how cost-cutting and rigidity lead to larger problems. Now, this will be a summary from Holman's case study on Boeing, which lists several major optimization failures regarding the 737 MAX, resulting in some catastrophic failures. The new 737 MAX was created to replace its 707 and 727 predecessors, with some major design changes added. Boeing changed the center of gravity and lift compared to Boeing's previous installments in favor of minimizing the trim drag effect and the optimized efficiency, neglectfully ignoring how it increased the plane's chances to stall. Rather than doing an aerodynamic redesign of the airplane, Boeing decided the quickest and least expensive fix was to provide a new software system called the MCAS, which attempts to make the 737 MAX aircraft behave like its previous 737 NG versions through flight control software algorithms. Recently, however, it's been discovered and reported that rather than using experienced in-house experts, Boeing outsourced much of the development and testing of the 737 software to temporary for hire software developers in India. Next, they proceeded to skip the certification process associated with softwares through the FAA's required testing and guidelines by obscuring its very existence, meaning there was no training models, there was no manuals created to explain what it was or how it acted, leaving pilots to adjust to a system they didn't know existed and was actively fighting against them, claiming essentially no additional training was required. This absolutely played a role into the tragedy that happened next. In fact, until the first crash of a 737 MAX in late 2018, no one outside of Boeing even knew of its existence, of the MCAS, or the design of the systems feeding the data into the MCAS. Speaking of which, they also skimped on the standard number of detectors that were supposed to be used for determining the angle of attack in the so the standard number of detectors is 4. For the 737 MAX, it was reduced to 2, and the MCAS only ever reads from 1. In the end, Boeing's over-optimization of costs and shareholder values in favor of the bare minimum standards resulted into the 2 fatal crashes of the 737 MAX aircraft occurring within 5 months. But enough of the sad things, now let's move on to something more positive. Quality improvement is one of the core drivers behind optimization efforts. When we talk about improving quality, we're not just looking at the final product. We're talking about improving every step of the process and that leads to it. For example, a consistent product reliability reduces the risk of returns and complaints, which saves money and builds brand trust. And when customers are satisfied, they come back. That loyalty is a direct result of quality. On the internal side, quality improvement also boosts employee morale. Workers are more motivated when the tools and systems they use help them succeed rather than cause frustration. Overall, investing in quality is one of the best ways to improve long-term profitability and reduce risk. It's not just about fixing problems, it's about preventing them before they happen. Now, space optimization might sound simple, just pack things better, right? But it's actually one of the most practical and impactful forms of optimization, especially in logistics and warehousing. Say, for example, you could fit 20% more inventory into a delivery truck without compromising safety. Well, you reduce the number of trips needed. That directly lowers your fuel costs and emissions. So there's also the cost-saving factor associated. The less space you need, the less warehousing storage, the less packaging material you use. And when done right, space optimization makes it easier to scale operations as demand grows. In my own personal experience working in a moving company, I've seen how strategic packing can make or take a brace schedule. Knowing how to arrange items by weight, fragility, and shape saves so much time and effort. And today I even tracked my efficiency for this presentation. Now, while working at the moving company, I tracked the amount of time spent loading and how it affected my overall job performance. In this scenario, the absolute maximum the truck can handle is 125 units, and that's how I calculated how efficiently I used the space of the moving truck. What I found is that at about 2.5 hours of loading is where I was doing the best. It's where I achieved the highest throughput at 17.42 units per hour. But beyond that, the time investment no longer paid off. Even though I was packing more efficiently, the overall rate of units moved per hour began to drop. This shows that even something as hands-on and moving can benefit from tracking optimization processes, but that over-optimization can hurt efficiency if you don't know where to stop. Now, here's a visual representation of my packaging efficiency and the diminishing return after achieving my peak throughput. So this is the peak that I had, and this is when the diminishing returns start to occur, and then it completely goes into the ground. So now, the benefits of optimization and how they relate to cost reduction. Optimization, when done right, directly leads to cost savings, whether improvising how space is used in a warehouse or how labor is allocated in a plant. You are essentially doing more with less. A simple layout change in a facility might seem small, but when you multiply that across a global supply chain, the savings are massive. That ties directly into what we've learned at the start of the class. The goal is to maximize value, and in supply chain, value often means cost efficiency. So while optimization can take more effort upfront, the long-term benefit is a leaner, more financially sound operation. Earlier, we discussed how chasing perfect optimization can sometimes backfire, especially when it adds unnecessary complexity. That's where efficiency gains can actually turn into losses. But as we discussed, that doesn't mean optimization isn't valuable. When done thoughtfully, it can make processes faster, smoother, and less wasteful. The challenge is in, once again, the balance. how much effort or cost are you putting in to gain those few extra seconds of performance? That balancing act between optimization and complexity is where the real efficiency is found. And that's where technology's role in optimization shines. In our discussion post, Jonathan brought up some great points about regarding the technology we have available and how they can easily simulate complex processes that could take humans months or even years to calculate by hand. The ability to record real-time data using tracking software and provide live results is what makes the world able to operate as it does today. While tools like AI, real-time tracking systems have made optimizations faster and more efficient than ever, they still heavily rely on us, the human element. Technology can simulate thousands of scenarios, but it can't understand the context, the judgment, or the values, or even the ways a person can. This brings us to the next important aspect, the human factors in optimization. While technology can process vast amounts of data, it's still humans who interpret the meaning behind the numbers and make the final decisions. For example, a scheduling algorithm might suggest the most efficient route or workflow, but it might not account for the worker fatigue, the environmental disruptions, or customer relationships. The human creativity also plays a huge role. Employers often find shortcuts or suggest process improvements that weren't visible to software. But there's also a flip side too. With too much pressure to optimize can lead to burnout. It's like what Elliot said in the discussion post, that he has seen on a first-hand basis where performance metrics push workers to the edge, decreasing morale, their long-term productivity, and they suffer from burnout. Lastly, the human factor shows up in how organizations adopt optimization. People may resist changes due to the fear of the unknown, lack of training, or comfort with legacy systems. This is why management and clear communication are just as important as any algorithm. Now, let's move on to our final two examples of some of the best successful optimizations in this business. Toyota and Amazon, the gold standards. Now, Toyota revolutionized the automotive industry with its lean manufacturing model. Their use of just-in-time inventory along with Kaizen or continuous improvement, creating one of the most efficient manufacturing systems in the world. Amazon, on the other hand, leads the digital age. Their use of automation, robotics, and real-time data tracking in warehouses and logistics allows them to ship millions of products quickly and accurately. Their supply chain is a masterclass in smart optimization. Both companies show how optimization, when applied strategically and with long-term goals in mind, can be a key competitive advantage, even with the extreme optimizations. So, when is optimization needed? It's like Abu Nasser said, optimization is needed when we clearly see inefficiencies, whether it's wasted time, space, or effort. It's also essential during scaling or growth, like when a company is expanding and it needs better system. And finally, optimization should be considered when key performance indicators aren't meeting their target. It's often a signal that you need to analyze and improve a process. So when should you not optimize? So not every situation needs optimization. Say for high stakes environments like your emergency rooms or patient care. Reliability is often far more important than squeezing out small gains, regardless of what hospitals choose to charge you. But it's also the process of working well, and the cost of implementing it is also high. So the return might not even be worth it. Over optimization in these cases can actually create more problems than it solves. Like take my moving example, where if I spent more time trying to be as efficient as possible, I would end up wasting far more time. Now for our conclusion. To wrap this up, optimization is a powerful tool, but it's not always about squeezing every last bit of efficiency out of a system. It must be balanced with things like usability, flexibility, and cost, especially in complex or human-centered environments. Avoiding optimization too early, you can spend a lot of effort solving problems that just don't exist yet, or designing for situations that will never happen. And you should always let data lead the way. Real metrics and performance indicators are how you know if an optimization is actually helping. In the end, the goal isn't perfection. The goal is balance, making systems work better, not just faster. Well, thank you for listening to my presentation for today, and I wish you all a good summer.